Hi everybody, I've had a request to explain how to do this question. It's about a pulse which is a non-symmetrical pulse going from a thin rope where it travels faster, and the thin rope is attached to a thick rope. So the red one is a thick rope, and so this is the before diagram. So that's the incident pulse. So we've got to say what happens on reflection. Now whenever a thin rope is attached to a thick rope where it slows down, this is taken as a hard boundary. So two things happen when it reaches the boundary. Part of the wave gets reflected back and part of it goes through or gets transmitted. So this is what the so when it goes slower, the frequency is the same for both. So in over here, when it goes slower, what we're going to see is that the wavelength is going to decrease, and because only part of the energy is gone through, the amplitude needs to decrease as well. For the reflected pulse, because the speed's the same, the wavelength doesn't change. However, because it's getting reflected off a hard boundary, then what goes as a crest needs to come back as a trough. Now it's going to be the reflection of this, so this part hits the boundary first, so that part's going to get reflected first, and this bit hits the boundary later, so that's going to get reflected later. So this is what the after diagram looks like. Okay, so we need to make sure this is exactly under that. Just say it's traveled the same distance in that time, and this arrow tells you the direction in which it's moving. The amplitudes are small, so these are the changes that happen. So in the after diagram, it's opposite phase. The speed's the same, the wavelength's the same. The amplitude has decreased because only part of the energy is reflected, but the frequency stays the same. Okay, and then for the transmitted pulse, that's your refraction. What's going to happen is the phase is the same. That means it's still a crest. What came was a crest, and it's slower. So the speed decreases. Speed decreases, wavelength decreases, so this gap is smaller than that one. That shows the wavelength. Frequency is the same, but the amplitude decreases. That means the height of the wave is less than the original height. So I hope that made sense.